Okay, welcome to your mock exam preparation for WJEC Engineering. This is everything that we have gone over the last couple of weeks to get you prepared for your October examination. I hope this video helps you. Anything that you want to skip through, anything that you want to double check, can be found on this video, but just remember as well that this PowerPoint is saved in your Teams folder. So please access any work that you need for revision through there. So first thing we're going to go through is measuring and marking tools. Now I'm going to go through these fairly quickly. If you'd like to pause the video, go back, please do so. But I'm going to try and keep this video as short as possible. So the first one is a scriber. So a scriber is a hand tool used in metalworking to mark straight, accurate lines on workpieces, usually before cutting or machining. It has a sharp, hardened steel point that scratches the surface to leave a visible line. So it basically does exactly the same thing as a pencil. The only difference is instead of using lead to mark, that you scratch it into the metal that you are working on or plastic that you are working on. After that, we've got a steel rule, so a straight measuring tool made of steel used for measuring and marking straight lines. It typically has metric and imperial units, which means that you usually have centimeters, millimeters, and also imperial, which is inches on there. We've also got the engineer square. An engineer square is a precision tool used to check and mark right angles at a 90 degree on metal or other materials. It consists of a steel blade fixed at a right angle to a thicker stock. So you've got the blade and the stock there, and ensuring accurate measurement and layout. Very, very similar tool to the tri-square or the carpenter's square. The only difference is that the stock on a carpenter's square or tri-square, if you want to call it that, is made out of timber with brass on there, whereas this is fully made out of stainless steel and a little bit smaller. We've got dividers. So dividers, a tool with two-pointed leg that you use for marking circles or arcs and for transferring measurement on metal or other materials. Again, does exactly the same job as a compass. Center punch, so marking out and creates a divot when struck with a hammer. So that divot is there to ensure that when you are drilling a piece of metal, that the drill bit on the pillar drill doesn't slip and it goes straight through the material, so you get that accurate drill point there as well. Here we've got a few exam style questions, so if you would like to try them out, please pause the video and go through these. So there's questions on the scriber, steel ruler, engineer square, dividers and center punch. Next we've got cutting tools. So tin snips. Tin snips, hand tools resembling scissors used to cut sheet metal. They come in straight, left and right cutting types. So just think of this as scissors for thin metal. Hacksaw and junior hacksaw. So a hacksaw with a fine-toothed blade used for cutting metal and plastic. And the blade is also replaceable and held in the frame. The junior hacksaw does exactly the same job, it is just smaller. So it is a smaller version of the hacksaw used for cutting thin metal rods, plastic and small workpieces. Coping saw. A coping saw has a thin, narrow blade held in a U-shaped frame used for cutting curves in wood, plastic or thin metal if you change the blade as well. And we've got the scroll saw or fret saw, can be called either. Does exactly the same job as a coping saw. The only difference is that it is powered, so it's a machine. So a narrow bladed saw for cutting decorative spiral lines or patterns on both thin wood and plastic. It can also be used to cut the inside of a material. Bandsaw, this is a machine that we have in the back room. A power saw with a continuous looped blade, hence the word band. So it literally is just one big blade spinning on two wheels, used for cutting curves or straight lines in wood, metal if you change the blade, or plastic, ideal for larger or thicker materials. So the things that you can cut through with a hacksaw or a scroll saw, coping saw, you'd use the bandsaw. On here, we've got some exam style questions if you'd like to pause the video and try them out. So we've got video questions on the hacksaw, junior hacksaw, bandsaw, coping saw, and also the scroll saw. Okay, technical drawing. This will come up in a moment, but I just want to clarify on here, when you are seeing a technical drawing, you need to say what you see. So make sure that you are going through the technical drawings and write down what you see in short sentences. Remember, every number that you see is in millimeters as well. So just a little thing for your coursework there. And in the future as well, if this pops up in your mock exam, in your GCSE exam, that you just say what you see. Next, we've got electronics, tools and equipment. So soldering iron, a device used to attach pieces of metal together. Solder is a metal alloy with a low melting point that's used to create joints between metal components when soldering. We've got the desoldering pump, a manually operated device which is used to remove solder from a printed circuit board. Snipe nose pliers, used to hold electrical components during soldering or for bending wires. We've got the wire cutters, used to cut wire to its desired length, hence the name. Wire strippers, used to strip the rubber casing around the wire, so exposing that wire for you to be able to solder it. And finally, we've got the PCB, so a printed circuit board, PCB, mechanically supports and electrically connects electronic components. Okay, so electronics is a very important part within engineering. With the rise of energy saving, clean energy and electrical products, the need for engineers is greater than ever. In this lesson that we have already covered, we are going to learn the basic meaning and uses of typical electronic parts and symbols. So on the left hand side here, there are a few symbols that might pop up in your mock exam. They might pop up in your actual exam as well in the future. If you would like to take note of that, please pause the video and write them all down. But we are going to go through the main ones that has popped up over the last 10 years or so. So we've got a cell and a battery. A cell is a single unit that converts chemical energy into electrical energy, while a battery is a group of cells that produce a steady supply of electricity. On here as well, we've got the voltmeter and ammeter, clues in the V and the A there. A voltmeter measures the electrical potential difference, so that's the voltage, between 2 points in a circuit, while an ammeter measures the electric current flowing through a circuit. Please don't get them mixed up. So a voltmeter measures the voltage, the ammeter measures the electric current flowing through the circuit. Now we've got the resistor and the variable resistor. So the main difference between a resistor and a variable resistor is that a resistance is fixed, while a variable resistance can be changed. Both control the flow of current. So on the left hand side there, we've got a resistor that is fixed. You can't change it. The amount that it can resist is set. Whereas a variable resistor, like a volume knob that you would find on a speaker or anything like that, that's a variable resistor. You can make it higher, you can make it lower, you can control the amount of current that runs through a electrical equipment. On here we've got a switch. So a switch is a controlled method of cutting power from the circuit. And on the right hand side we have a motor, a big M in the middle there to remind you that it is a motor. So a motor is used to power a product. And finally we have a lamp and an LED. So on the left hand side we've got the lamp. The symbol for the lamp is there as well. So a lamp is used to provide light on a circuit. These are usually halogen lamps. And on the right hand side we've got LED. So LED or light emitting diode might pop up in your mock exam or GCSE exam as that. Are very rugged, so they're tough and produce a brighter light than a traditional lamp whilst using less energy. They are considered, because they use less energy, more environmentally friendly because of this. Next we've got machinery. So laser cutter, a computer controlled machine that uses a high-powered laser beam to cut or engrave materials like wood, plastic, acrylic, fabric, or thin metal with high precision and accuracy. It's ideal for detailed designs and complex shapes. Remember, to get a laser cutter working, a laser cutter is a CAM machine, computer aided manufacture. You also have to have that CAD, so computer aided design. In this school, we use TechSoft. We design everything on that CAD program, TechSoft, and then send it to the CAM, which is the laser cutter, for it to be cut. On here, we've got a center lathe. So metal turning lathe, particularly centered or engine lathes, are commonly used for machining metal parts. A workpiece secured in a chuck is turned against a tool which cuts metal from the workpiece. And with this, we've gone through this so many times now, where a metal can be cut, it can be shaved down, you can have a threading tool that adds a thread onto metal, you can have something that knurls the metal as well. If you are unsure what these look like, go into that PowerPoint in your Teams folder and you will find the YouTube shorts there showing you each one of them. Next, we've got a CNC router. So the CNC router and milling machine goes hand in hand. But a CNC router is a computer-controlled cutting machine that uses a rotating bit or tool to carve, cut or engrave materials such as wood, plastic, foam and soft metals like aluminium. It's widely used for precise, repeatable work in industries like cabinetry, sign making and prototyping. The CNC stands for Computer Numerical Control, indicating it operates based on programmed design. So again, using those CAD designs. Milling machine does exactly the same job. The only difference is that it cuts through thicker stuff as well. So a milling machine is a powerful tool used in engineering and manufacturing to cut, shape or drill materials like, again, metal, plastic or wood. It uses a rotating cutting tool, same as a CNC router, to remove material from a solid block called a workpiece. Now the main difference between these I'll get to in a second. But how does a milling machine work? So the cutting tool, called a milling cutter, spins at high speed. The workpiece is held on a flat surface called the table. The table can move in different directions, usually left or right, so the x-axis, forwards or backwards, which is the y-axis, and up and down, which is the z-axis. The machine moves either the tool, the table, or both, allowing very precise cuts to be made in a variety of shapes. And the differences between them, again, very, very similar. The main difference here is the milling machine can get you a cleaner and more precise cut, and the milling machine cuts through thicker, denser materials like metal. It can go through wood, plastic, aluminium, but if you want to go through something like titanium, stainless steel, you'd use a milling machine. The reason for this is the CNC router has a high spindle speed, so often over 10,000 RPM, which is ideal for soft materials. However, the milling machine, much lower spindle speed. We're looking at 1,000 to 6,000 max RPM, but with more torque, better for metals. The way that I describe this for you, think about what's the strongest gear on a car. It is the first gear. Yes, you're not going as quick, but you can't start a car going uphill in fifth gear. So the lower the number, the stronger the torque. On here, we've got some exam style questions. So laser cutting, CNC router, milling machine, laser cutting again, center lathe, milling machine, and a couple of general there as well, questioning about CNC.